Okay, today we are going to, I say, review properties of radicals. But depending on what class you came from, you may not have done much with this. So the notes are attached below the video. You may want to go through those as you see what's going on. But this was something some of you may have done in 8th grade Algebra 1. Usually they try to do it in geometry, but because of last year, we may be a little bit behind. So again, it's just something that I'm going through this stuff now so that we have it for the rest of the year. And it's stuff that's easier for me to do probably with you online. So when we talk about reducing radicals, there's two sort of things you want to remember with radicals. A radical times a radical is the radical of that product. You know, if I wrote down radical 18, I could write down that is radical 1 times radical 18, radical 3 times radical 6, or radical 9 times radical 2. Same thing with division. I could do the quotient, the radical A divided by radical B is the same thing as the radical of A over B. So I just showed radical 2 over 25 is radical 2 over radical 25. So that's really me just showing you that. So a radical is in simplest form when no radicand, which is a radical, has a perfect square factor other than 1. The radical has no fractions, and there are no radicals in the denominator. Now, the first thing we have to know are what are perfect square factors? Well, your perfect squares are taking your first numbers and squaring them. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared, etc. 49, 64, 81. Like if you were in my room, you would see that I have these up on my wall. But how do you generate them? 2 squared, 3 squared, 4 squared, 5 squared, etc. So what I'm going to do is really just go through each rule and show you a couple examples. But I don't want them done out. So first thing, no perfect square factors. So you look at a radical such as radical 8 and you say a factor is a number that goes into that number. Does 4, 9, 16, 25, etc. go into 8? Well, yes, 4 does. So I then use that first rule. Radical 8 is radical 4 times radical 2. But when I look at that, I know that the square root of 4 is 2. I do not know the square root of 2. The square root of 2 is the square root of 2. So I look at something like square root of 80. And I say, okay, well, what's the square root of 80? Well, the square root of 80, does any perfect square go into it? 4, 9, 16, 25, 36. And you sit there and you just start dividing. So some people that go forward, they'll say, yeah, 4 times 20 is 80. Well, square root of 4 is 2. Square root of 20, I don't know. But I can't have a perfect square factor. 20, 4 goes into. So then I'd have to do it again. That 2 would stay. Square root of 4, square root of 5. Well, that first 2 stays. Square root of 4 is 2. Square root of 5 I don't know. That is 4 square root of 5. Now, you could have finished this quicker by using the largest perfect square. So instead of starting and going up the line, go backwards. 80 is not divisible by 64, 49, 36, 25, but it is divisible by 16. I know that the square root of 16 is 4. I don't know the square root of 5. So that would be my answer, quicker than picking the smaller number. I just had more examples, but we don't really need to worry about those. Like something like this, square root of 98. You know, what goes into 98? 49. 49 goes into that 2 times. Which one of those do I know? The square root of 49 is 7. I do not know the square root of 2. So the second rule, just sort of moving, a radical cannot be in the denominator of a fraction. And I forgot to change this. I wrote denominator. Denominator. So first thing you should always do with a fraction, split it up. Radical 5/4 is radical 5 over radical 4. You do not know radical 5, but the square root of 4 is 2. You're done. Because do you have a radical in the bottom? Nope. You're good to go. So what happens? I'll do another one. This one, same thing. Split it up. Square root of 16 over square root of 81. Do the square. If they're perfect squares, you know their square roots. Square root of 16 is 4. Square root of 81 is 9. You are done. So, if we can't get rid of that bottom, what we are going to use is something called the conjugate. The conjugate is a word you will see, like my pre-calc. We went over conjugate the second day of school and said, hey, you remember that word, conjugate. The conjugate of radical b is really negative radical b. The conjugate of a plus square root of b is a minus square root of b. The conjugate of a minus square root of b is a plus square root of b. So you're going to see it with complex numbers also. So really this comes in when we have things that we cannot get rid of the radical after we split it up. So we would have square root of 5 over square root of 2. Square root of 2 is not a perfect square. So if it's a radical by itself, monomial, you don't really have to use the conjugate. You just multiply by itself. So if I choose to multiply the bottom by square root of 2, I have to also multiply the top by square root of 2 because I learned that a long time ago. Whatever I do to the bottom, I do to the top. Well, radical 5 times radical 2 is radical 10. Radical 2 times radical 2 is radical 4. But now I know that. Radical 10 is radical 10, but radical 4 is 2. I can't have a radical in the denominator. So I would have to use the conjugate if I was given a question such as this. 3 divided by 7 plus square root of 2. You can't multiply by radical 2 and get rid of it. So you have to multiply by 7 minus radical 2, the conjugate of plus. Whatever you do to the bottom, you do to the top. So now you multiply, distribute. 3 times 7 is 21. Remember, you can multiply anything times anything, but a number outside a radical is not going to go under the radical. 3 times square root of 2 is 3 times square root of 2. Sort of like 3 times x. So then here, 7 times 7, 49. 7 times a negative square root of 2 is a negative 7 square root of 2. Now I'm going to take the second thing. What's square root of 2 times 7? 7 square root of 2. But now what is radical 2 times radical 2? They're both under the radical, so I can multiply 2 times 2, but it stays under the radical. Now you look at that. Those are like terms, but they're opposites. They cancel out. That's 0. So I got 49, but square root of 4 is 2. 49 minus 2, 47. We can't have a radical in the denominator. I got rid of it by using the conjugate. Now, I'm not going to do this one, but you will have one. If you have like binomials on both, remember it's the conjugate of the denominator. So 4 plus square root of 5. If I did that on the bottom, I do it on the top. But when I do this one, I'm going to have, 4 things there, 4 things here, but the thing that should be gone is the radical in the denominator, not the numerator. You can have a radical in the numerator. So try that out. As I said, some of you may know more than others with this, just based on what you took last year.